1.3, more on functions. Just a quick reminder, everybody, you are testing tomorrow. We already talked about this, so get your study on tonight. Today we're doing a few things. Identify the intervals in which a function is increasing, decreasing, or if it's constant. We'll use a graph to locate what is called a relative maxima or relative minimum. Identify whether the function is odd or even. Recognize their symmetries. Understand what a piecewise function is, and then find and simplify functions difference quotient. A function's difference quotient. A difference quotient. Ooh. That's going to be fun. All right, you guys ready?
Yes.
Let's get to it. If we don't get through this whole thing, it'll be okay. This is kind of, it looks blah. It looks blah. But here, all you really need to know is as x is getting bigger, if y is getting bigger, then you're increasing. That should make sense, right? If x is getting bigger and y is getting bigger, then the function is increasing. If x is getting bigger and y is getting smaller, then your function is decreasing. If x is increasing and y is not changing, then your function is being constant. That's all this is saying in fancy math. Okay? Now, if you want to know the fancy math, it's right there. But I think we understand that idea, right? As I move across to the left and y gets bigger, my function is increasing. As I move to the left and my y values get smaller, then I'm decreasing. And if I'm moving across to the left and my y's are not changing or they're equal, then that means that it's just being constant. What's up? How y is reacting to x. And all we're really learning to recognize is if the function is increasing or if it's going up, if it's decreasing, going down, or if it's remaining constant, like x equals, like y equals 5 or something. Say that one more time? Yeah, we're really looking at what y is doing. Once you see the visual, because I think you're very visual. Am I wrong? No? Okay, then never mind. Seeing the image helps a little bit. Okay. Seeing the image helps. I can get rid of this. Anybody writing any of this down? This mumbo jumbo? It's good mumbo jumbo. Isn't that trippy? Try reading it, right? A function is increasing on an open interval if I, interval, we'll call it I, if f of x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2, for any x sub 1 and x sub 2 in the interval. No, mathematically it's correct. So if you're doing like mathematical work and you want to send it off to somebody to look at it, you need to describe it in terms that any mathematician will be able to decipher. Does that make sense? You have to have rules, and those are the rules. Yeah, of course you can. Pass this right over there. Okay, so check this out. You guys ready? So here's an image, and we are going to determine whether it is increasing, decreasing, or constant. So when I look at this image, how do we read our functions or our graphs? Left to right, just like we read our books. So what's my function doing right now? Increasing until it gets to -1. So I can say it's increasing on the interval from negative infinity all the way to -1. Is that the only time? Well, at that point, at this decreasing point, it starts to go down, doesn't it? So I'm decreasing from where to where? Yeah, so I'm decreasing from -1 to 1, and then I'm increasing again from 1 to positive infinity. That's all we're doing. Is my function increasing, decreasing, or is it being constant? Is there any part of this function where it's constant? No. This thing will increase until it gets up to here, and then it'll start to drop. Questions on that? Give me thumbs up if you're good. Give me thumbs down if you're not. All right, cool. There are two relative values here that we want. There's a relative maximum here at -1, and there's a relative minimum over at +1. You see that? A maximum is a high point. Here's our relative max. Here's a relative min. What is our max here? What is our real max? Infinity. What's our real min? Negative infinity. But we can't do much with those numbers. We really care about what's going on here at this point. Questions? All righty. Can I change the slide then? Good? Oh, we just said it. So we'll just skip that. Okay, here we go. Even or odd functions. A function is going to be even. A function is going to be even if I plug in a negative x and I get back the same function. Okay? It's going to be considered an even function. So, and we'll have an example in a minute. But if I can take my function and plug in the opposite of the value and I get back the original function, it's considered even. If I plug in a negative function and the whole thing becomes negative, then it's considered odd. Oh, excuse me, Mr. Chair. They feel loose on my face. It looks like you. After a while, they do that. I think this one's a little bit. Okay. Did that make perfect sense? No. Thank you. So let's move on. Check this out. Determine if this function is even, odd, or neither. Ready? So here's what I'm going to do. My function is h of x, where x to the fifth plus 1. What I'm going to do is I'm going to replace x with a negative x. So I'm going to plug that in. I've got negative x to the fifth plus 1, correct? I've taken x and I've replaced it with negative x. Then I have this, don't I? So here's where you need to compare. This is my original function. Here's what I got when I substituted negative x. Did I get back the original function? Did I get back the original function? No. What's different? X to the fifth is now negative. What about the other guy? Did the other guy change? No. So this is not even. If it was even, I would get the exact same thing back. Does that make sense? If this was odd, then everything would change signs. Did everything change signs? No. What did the x to the fifth change signs, but not the 1. So this is neither. This is not odd nor even.
Neither here nor there.
Nor here nor there, nor everywhere. A graph of a function in which f of x symmetric. What? Where's my example?
I'm sorry. It's kind of just like my own thing.
I think we need more problems, right? Y is equal to x to the fourth minus x squared. Okay? Let's determine if this is even or odd. Go ahead and try that out. That's kind of easy to see. So the ones you have to worry about are the degrees. Okay? is it graph? No, don't do that.
Just figure out if it's even at all.
Yeah, just figure out if it's odd or even for now. I already got somebody answer this. Raise your hand if this is even. Raise your hand if it's odd. Raise your hand if it's neither. Good. So, just to repeat it and beat this horse to death, because it's not dead yet, right? We haven't listed on it. If none of, sorry, if you plug in negative, I ruined that, didn't I?
Oh, no.
If you plug in a negative x and nothing changes, then it's even.
Okay, that's
If you plug in a negative x and everything changes, then it's odd. If you plug in a negative x and something's changed and something's don't, then it's neither.
I had to write that down.
Then it's neither. 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 Oh, no, this is important to know. This is important to know. If, thank you, if a function is even, it's going to have y-axis symmetry. Think about your parabola. Parabola. See how I can flip that bad boy and it will look exactly the same? That only happens with even functions. Okay? If it's an even function, yeah. If I have an odd function, it's going to have symmetry with respect to the origin. Odd functions will have symmetry with respect to the origin. Think about the cube graph. It looks like this, and then the other half goes down, right? And if this was symmetry about the origin, where's my cloner? Here it is, thank you. So, I could take this and I could flip it over the x, so I could flip it up down, which would mean here, correct? And then I would also have to flip it across this way. And where's my flip again? Here we go. Flip it left to right, and then that is the graph of the cube function. So it has that symmetry across the origin. Okay?
Mr. Ross, I don't even know about the flips.
What does Mr. Ross know about that? I'm just kidding. I heard someone say it, so I'm just repeating it.
You know what?
Questions on that? We're good? Math wars.
Are you and Mr. Rosa best friends?
No, we're not.
Are you and Mr. Malik best friends?
No, but I really like him. He's cool. I like Mr. Rosa too. I like everybody I work with. Yeah, a little homo in there. Just because of the face she made, I had to say it. She just kind of go like, oh my goodness, like now I have to delete this because I sent it on live.
Oh, yeah.
Oh, you guys are horrible. The things you make me say. Moving on. Yeah, now I can't do this.